As you can see, there are some discontinuous areas where the lines either need to be extended or need to be trimmed. For extending lines, we can use the Combine and Extend Lines tool in our GFEM Builder ribbon. After we select this tool, be sure that the drop-down menu is set to Extend, the Choose Target checkbox is selected, and the target is set to Lines. And then, with the target drop-down menu selected, we can select the destination that we are wanting to extend our lines to. Likewise, with the Lines box selected, we can select the line that we are wanting to extend. By pressing the green checkmark, the line will be extended, and we can follow the same procedure to extend the second line. These lines can be trimmed by using the Split With Lines tool. First, we must ensure that Lines is selected for the Target drop-down menu. We can select the two lines that we are wanting to trim. Following this, we can select the Tool button and select the two lines where we are wanting to perform the trim. By pressing Split, the overlapping line portions are divided into separate lines, and we can delete them by changing our selection to Lines, selecting them, and pressing Delete. Now that we have sufficient line quality, we need to check the fuselage surface. On the surface of the fuselage, several edges are present. These edges are indicated by the solid black lines on the surface of the fuselage. HyperWorks has the ability to suppress edges, which are indicated by the dotted lines on the surface. In this context, suppressing the edges of the fuselage will hide the current edges and allow us to imprint the lines onto the fuselage surface without any interference. I have already suppressed several of these edges on the fuselage, but we can suppress the remaining edges by selecting Suppress Edge and clicking on the solid green lines, causing them to turn into dotted blue lines. By exiting out of the tool, these edges are now suppressed. Now that the lines and fuselage surface have been prepared, we are now ready to imprint our lines onto the fuselage surface by selecting the Imprint tool. Making sure that the source box is set to Lines, we can isolate the stringer and frame lines and drag to select all of them. Then we can select the target box and select the surface we are wanting to imprint on. As you can see, the highlighted section of the fuselage is considered one surface since we suppressed its edges. We can now press Imprint. The lines have now been imprinted onto the fuselage surface as edges. At this time, we can fix any discontinuities in the edges by using the Split Interactive tool. Once you select the tool, a discontinuous section can be patched by clicking and holding on one point and dragging to another. This edge is now continuous. Now, let's create a 2D shell mesh for the section we have been working on. We will select our surfaces and use an element size of 40. After the mesh has been created, the density tool can be used to edit the density of the mesh and improve its quality. To uniformly change the densities of the frames and stringers, we can open the options of the density tool. Under the Advanced section, the Link Opposite Edges drop-down menu can be set to Uniform Distribution. With this, changing the density of one frame section will change the densities of the same region on the remaining frames. In this case, I'm using a value of 4. As you can see, this step can be used to establish a uniform density across the fuselage and remove any tria or distorted quad elements that result in poor mesh quality. This same step can be performed for the stringers of the fuselage. For this, I will use a value of 16. Another method of improving mesh quality would be to create our fuselage mesh using the Panel Mesh tool. This tool will generate a mesh without the use of tria elements and will automatically apply a uniform density across the part. Similarly to the 2D General Mesh tool, we simply need to select the surfaces that we are wanting to mesh, define our element size of 40, and press Mesh. Once this is done, changing the viewing settings can help to better visualize our new mesh, which is made entirely with quad elements. To add a thickness to this mesh, we can click on the component where the mesh is located, right-click on Property, select Create, and add a value to the thickness section. Although the thickness is always present in the properties of the mesh, viewing the thickness in the graphics window can be toggled on and off by changing the viewing settings. Finally, renumbering the element IDs of our 2D shell mesh can help further its organization. Establishing a nomenclature for the element IDs will aid in locating individual elements for further analysis. This renaming process can be performed by going to the Assembly tab, and clicking on Spatial Renumber. Once the tool is opened, we will change the setting to Adjacent Renumbering, change the selection type to Elements, and in the Advanced options, press the checkbox for Show IDs on Selection. We can then select our elements, which will show all of the current element IDs. As you can see, the current element IDs do not follow an easily interpreted pattern, making quick element location difficult. To establish our renumbering algorithm, we will click on Options. First, we will choose the element 1380, which will be the starting element of our renumbering algorithm. Upon selection, the current ID of this element will appear in brackets in the Start button. Following this, we will select the primary direction that our renumbering algorithm will follow. For this, we will select the element 1379, which follows the longitudinal direction of the fuselage. The increment window below the primary button will establish the increments in which the element IDs will increase along this direction. Finally, we will establish our secondary direction. For this, we will select the adjacent element in the positive y direction, which is element 1382. To add an increment in the secondary direction, we will need to click the Continuous Increment button in the micro dialog box. Then, we can add an increment of 100 in the increment window. Since our mesh is two-dimensional, we will not need to establish a tertiary direction. When we press the black arrow, we can see that, beginning with our start element, the element IDs are now numbered from 1 to 59 as they extend along the longitudinal direction of the fuselage. Additionally, the row of element IDs adjacent to this begins from 101 and extends to 159. This pattern continues for the whole fuselage, allowing for easier location of individual elements.